A population grows according to the following exponential model. Y equals 112 e to the 0.164t, where t is measured in days. What will the population size be after 14 days? Round to a whole number. Well, the population size in days is measured with this function. So even though it just says y, it's really y of t. So we can input a number of days, and then the population size, which is the output, is given by 112 e to the 0.164 times however many days we're interested in. So if we want to know how large the population size will be in 14 days, we can just take y of 14 and evaluate this as 112 e to the 0.164 times 14. And that's something that we can come up with in our calculator. So let's bring that up. And to do this, we would do 112 times, if I hit second and divide, that will give me e. And e here is just the base of the natural logarithm. It's like 2.718 and a decimal that goes on forever, but the calculator knows that value. So we just put in e. Then that's raised, and then in parentheses, I'm going to do 0.164 times 14, because that way it'll make sure to do the multiplication first, and then make sure all of that is in the exponent. So we get 1,112.6 days, so we round that to a whole number. We'll say 1,113 days. Now the next question asks, how long will it take for the population size to reach 1,037? And to round our answer to one decimal. So we have the same model to work with. It's y of t equals 112 e to the 0.164t. But this time we have an output value of 1,037. So that's a population size. So the function evaluated at some time outputs a number. So we're going to replace the function itself with 1,037. So that would give us 1,037 is equal to 112 e to the 0.164t. And if we divide both sides by 112 to get the exponential function by itself, that is. And I'm going to leave this as a fraction for right now. And that's only because this is a multi-stage problem. And anytime you have a multi-stage problem and you round off at intermediate steps, you can run into a problem with having rounding error in your final answer. So even though you've done everything correctly, you could be marked incorrect simply because you rounded at intermediate stages. So to prevent rounding, just leave fractions as fractions. Okay, so now I have an exponential function. So this is in exponential form. And I have a variable in the exponent. So what I need to do is get that variable out of the exponent. The only way to do that is to change into logarithmic form. So it's going to be a log base e, because my exponential function is base e, of 1,037 over 112, so this number over here, and that's equal to the exponent, so 0.164t. Or instead of saying log base e, we can call that a natural logarithm. That's the definition of log base e. So here we are. Now to get t by itself, all I would need to do is divide both sides by 0.164, and that would tell me the amount of time. So in the calculator, We can evaluate now. We can say this is the natural log of 1037 divided by 112. And this is all inside the logarithm, so I'm not closing parentheses too early here. Then that will get divided by 0.164. So that gives me 13.57. And it said to round to one decimal, so that would be 13.6. And then that's measured in days.